Next, we're going to be looking at how to find or determine points at which a tangent line to a curve has a certain slope. That is, points at which the derivative has a certain value. Now this is important. Finding slopes of tangent lines can help us solve many optimization problems, for example, problems in business or social sciences, for example. But first what we're going to do is review how we find an equation of a tangent line to the graph. And in this case, we're looking at the function f of x equal to 2x cubed minus x squared plus 2x plus 5 at the point 1, 8. Now recall, in order to find the equation of a tangent line, we can find that by simplifying the following. Y minus f of a equals f prime of a times x minus a, where f prime of a is our derivative at our a value. In this case, we can think of a as 1 and f of a is 8. That is our function value at a equal to 1. So our first step, what we'll do is we'll find our derivative at a value of 1. Now in the past we've used the limit definition to find the derivative. Now that we know about the power rule and the sum difference rule, we can use that to find the derivative. So f prime of x is equal to, using our power rule to find the derivative of 2x cubed, we can bring the 3 out in front and then subtract 1 from our exponent. And then we have a minus x squared. Using the sum difference rule and the power rule, we're going to bring the 2 out in front, bring the exponent out in front, and then subtract 1 from the exponent. Moving on to our next term, we have a plus 2x. So plus, carry the constant along with us. Now remember, the derivative of x is just 1. So times 1. Plus, and then recall the difference of a constant. We're taking the derivative of a constant here. The derivative of a constant is just 0. So now simplifying, we have 6x squared minus 2x to the first power plus 2. That's our derivative. Now we want to find the derivative at a equal to 1. So now f prime of 1 is going to look like 6 times 1 squared minus 2 times 1 plus 2. So our derivative is a 6 minus 2 plus 2, which gives us 6. So that is our derivative at x, or a value of 1. So that is our slope of our line. Recall that the derivative gives us the slope of the tangent line at that point. So we can plug that into our equation. So now we have a y minus our f of a is 8, equal to our slope of 6 times x minus a, and our a value is 1. So simplifying, we have a y minus 8 equal to 6x minus 6. Add 8 to both sides, and we have a 6x plus 2. So that is our equation of our tangent line at the point 1, 8 of that function. Now, if you would rather use slope-intercept form for writing the equation of a line, you can use that instead. So here's an alternative option. So you still have to find the derivative, and we found that the slope was 6. So we're going to use that. So plugging the slope in, we have a 6x plus b. Now what we're missing here is our y-intercept, our b value. But using our point 1, 8, I'm going to plug 8 in for y and 1 in for x. So now we have 8 equal to 6 plus b. Subtract 6 from both sides, and we get that b equals 2. So that's our y-intercept. Plugging that back into our y-intercept, slope-intercept equation, we have y equal to 6x plus 2. Notice we get the same equation for our tangent line. In this example, we're considering the function y equal to 3x squared minus 5x plus 4, and we want to find the points on the graph at which the tangent line is horizontal. Now the derivative is used to find the slope of a tangent line, and since a horizontal tangent line has a slope of 0, we want to find all x values for which the derivative of the function is equal to 0. So we want to know when is the derivative of 3x squared minus 5x plus 4, when is that derivative equal to 0? So let's take the derivative using the power rule and the sum difference rule. The derivative of 3x squared, bringing the 2 out in front, leaving the constant there, and then subtracting 1 from the exponent. And then the next term there, we have a minus 5x, so a minus 5. Using the power rule, we would bring the 1 out in front and subtract 1 from the exponent, keeping in mind the derivative of x is just 1. And then plus 4. The derivative of a constant is just 0. All right, and we want to know when is this equal to 0. Well, let's simplify the derivative here on the left-hand side. We have a 6x minus 5. We want to know when is that equal to 0. So let's solve this equation. So let's add 5 to both sides, and then divide both sides by 6. So when x is equal to 5 over 6, we have a tangent line that is horizontal or equal to 0. Now this gives us the x value for our point. So to find the corresponding y value or function value, we need to take this x value and plug it back into the original function. So we're going to take our y value is going to equal to 3 times 5 over 6 squared minus 5 times 5 over 6 plus 4. Let's simplify that, and that'll give us our y value. If we simplify that, we get approximately 1.9 rounded to 1 decimal place. Now if we take and round our x value to 1 decimal place, 5 over 6 is approximately 0.8. So now our point at which the tangent line is horizontal is the point 0.8, 1.9, rounding both our x and our y to 1 decimal place.